Everyone, and thank you for joining our webinar this morning, Upgrading Your Air Filtration. Don't forget the belt drive. A few more people, looks like they just joined in on the blue jeans, so we're going to let them get their email link and click in, and we'll get started in a minute. Again, thanks for joining. This will definitely not be the full hour, and I'll go through a couple of ground rules and introductions in a moment. Okay, looks like somebody else just joined. Okay, so we'll get started. Good morning, everyone. I'm Ian Rubin, Director of Customer Experience for Regal Power Transmission Solutions, and I'll be moderating the webinar. Thanks for joining. With me today is Jesse Dupuy of Regal and Sean Carnes from Frank Tracy Division. Jesse, let you introduce yourself to everyone.
Yeah, hi, I'm Jesse Dupuy. I'm Director of Marketing for our HVAC division for Regal Beloit. Been with us for, about a decade now, and all of that time I've really spent in belt drives, focused in the HVAC industry. So got a lot of field work experience, got a lot of OEM and user specification type work, and yeah, this is kind of my life, is working on this stuff. So looking forward to this.
Jesse and Sean, since most people probably know you, but a little quick introduction.
Good morning, everybody. I have the advantage of being able to put some faces to the names I see on screen here. So we're excited about having you this morning. One thing, you guys do know me, but you may not know that I've worked with both of these folks, having been with Regal and Emerson prior to joining Frank Tracy. They know their stuff. Jesse has actually been to the cities. You may have seen some, he may look familiar to some of you. But I contacted Jesse not long ago, and we talked about, the impact of MERV, and he actually happened to be working on something at that same time, and we decided to put today's webinar together. So we're excited to have you join us, and we're looking forward to Jesse's presentation.
Great, thanks, Sean. So a couple of ground rules or a couple of things. On your screen, you do have, when Jesse shares his presentation, you have the ability to increase the size of the presentation or the size of the video. So you'll be able to do that. We will do some poll questions, so you will see on the far right of the screen, there's a box for poll questions. A poll question will pop up. You can answer it. There is also Q&A, so if you have any questions, you could ask it there. We will either answer them during the presentation, depending on the questions, or at the end. And then there's also a chat box if there's anything you want to chat about or technical problems or ask a question there, but if you could use Q&A. So, just real quick, want to test the poll question, just to get one out there, real quick, just to give everybody a warm up to see what it looks like. So I'll start that in a second. And again, it'll pop up, say poll question has started. And then you could just answer that again. It's just a warm up just so you could see where the box is. And we'll ask a few throughout the presentation. Try to make it as interactive as we can is the goal. So please use the Q&A and the poll questions. The first poll question is up, and it's, again, have you completed your holiday shopping yet? If I was going to answer it, I would say no. So we got a couple of no's already, a couple of yeses. Wow, a lot of people ahead of me, so about 67%, 75% are done. So congratulations, you're ahead of the curve, I think. So with that, I'll end the poll, and then we'll hand off to Jesse. I will mute my camera and Sean's camera and mic, but we will be back during Q&A and during the presentation. All right, Jesse, whenever you are ready, you could share your screen.
Okay, thanks, Ian. Thanks, everyone, for attending. I'll honestly say it never ceases to amaze me that I do belt drive training and presentations and webinars all over the country, all over the continent. I've even done some overseas, and the amount of people that attend, it never ceases to amaze me. I love it. We're talking about belt drives here, and more often than not, people don't really consider that a piece of technology. I've heard it referred to as dirty rubber bands, and a lot of times it gets the amount of attention as the preconceived ideas that some people might have. So, when I speak to belt drives being a technical piece of the overall system, and and have an important role to play in the efficiency, it's often something that I'm trying to dispel people's ideas of what that really is and what that really means. But I know we asked some poll questions to begin this webinar, and I was actually pleased and surprised to hear that there was a lot of attention that people do already place on the belt drive in terms of the importance it plays in the system. So that's really great. That's a good starting point. And I'm going to build off that. So like Ian said, I'd like to make this as interactive as possible. I'm going to be speaking to a lot of these elements that you see on the screen here in the agenda, but really, I mean, if you have questions, ask them, don't wait until the end. I don't want this to be, everybody's held their questions to the end and then we go through them and you might forget some of them. If there's something that's relevant that you think you would like me to answer on the spot, feel free to jump in and do that. And Ian can interrupt me and he can take that question. So we're going to go through some of the expert recommendations on, MERV rating upgrades and, improving the overall airflow and the recommendations that various bodies have said that we should be doing in order to ensure, we're mitigating the risk associated with, the potential COVID exposure people will have inside buildings. What should be done? What are the impacts on the systems? What are some of the best practices when it comes to the belt drives that, we have learned through experience and through testing and development? And then I'm going to get into the efficiency itself of the system. I'll talk about V-belt drives. I'll talk about their design and function a little bit. I do have a new product I'm going to get to talk to you guys about, which I'm very excited for. And then I'll get into our retrofit program as well. So lastly, I'll end it off with just any available tools and some assistance that we have to be able to support you and to help you get through some of the stuff that we'll talk about in the prior slides. And then lastly, call to action. So I know everyone here is from New York, and I know that New York went through their big spike in COVID earlier on in the springtime. So I know that a lot of people have probably already done a lot of these recommendations. I'm going to reiterate some of these just as a grounding point to kind of start off the discussion. ASHRAE has made recommendations for improving air quality in buildings. The thing that we all are now super aware of, and even more so now that the winter is coming and people are starting to be indoors more often, we have always known that airflow and air quality and filtration and all that were important, but I don't think that it had the level of urgency that it does now. When we talked to people about belt drives, and I've been talking about belt drive efficiency for years, it was more centered around sustainability and energy consumption and things, and the ways in which we can reduce that energy consumption. Well, this kind of has forced us to pivot that discussion now around being much more focused on the safety, and reliability of these systems, making sure that they're operating properly, again, so that we can, not only improve the occupancy comfort, which is the fundamental purpose of all HVAC systems, but also to make sure that we're mitigating risk associated with all the different types of viruses that are airborne, and you can see them listed at the bottom. So some of the recommendations I just like to highlight, running all your ventilation equipment at least 2 hours before occupants arrive or 24/7, running nights and weekends, at least on low settings, switching air handling units with recirculation to 100% outside air. Now that's going to be obviously very, very difficult because that's going to put a lot of strain on the systems from a heating and cooling a heating standpoint. But, running ventilation in restrooms 24/7, there's also been a lot of studies that have done now to determine that restrooms are an important place that we also have to make sure that we've got good air quality so that we mitigate the risk again. This all comes down to, proper airflow, proper air changes, proper filtration. And it's, like I said, more important than ever. So, what do, right? If you look at the chart on the right, this is the risk of infection as a function of filtration. Obviously, we don't have a lot of systems or a lot of buildings that have zero filtration. There is some sort of filtration. And from what I've understood about what New York has done ahead of this is, you have made the move to MERV 13, which is what, the ASHRAE and CDC and EPA, they're all recommending going to MERV 13. I think you guys have done that. That's a 67% improvement over MERV 4 when you talk about the risk mitigation from an infection. So it's a super important move. You guys have made that move from what I understand. If you have not made that move, obviously that's what we're recommending. That's the number one most important thing. That said, when you think about improving that MERV rating, you're also increasing the resistance that the filter is placing on the system. So that's increasing things like static pressure. What that does also is that actually puts additional strain on all the components that have to pull that air across that filter. So things like the belt drive, there's increased strain now on the belt drive. The motor, depending upon what level of MERV you go to, you actually can overload the motor. So there's considerations that need to be made when you just make that filter upgrade. So I want to talk to you a little bit more about the actual specific belt drive itself, because the belt drive's the component that I think, if I had to guess, most of you have just replaced like for like. You might have, replaced some of the shivs. You might have just replaced the belts, but, in ensuring that they're all operating at peak efficiency, that's one thing that's really difficult because there's not a lot of means to determine that with the systems and the building management systems that you have right now. So I'm going to speak to some of those individual components.
Hey, Jesse, I just kicked off a couple of seconds ago the poll question of have you already made the upgrade to MERV? So we'll see what some of the feedback comes in as we go.
Yeah, sure. Sounds good. So speaking now in terms of the belt drive specifically again, we put together some best practice recommendations. The thing that's happened, obviously, like I mentioned, New York's gone through this back in the springtime. You're about to go through it again. I mean, it's happening all over the country, all over the continent, all over the world. This is the second, sometimes even the third wave that we're experiencing right now. It's going to shut down a lot of buildings. People are going to work from home, so a lot of the commercial buildings have been closed down or are operating at limited occupancy. When you shut down a building, when you shut down the systems on that building, either they completely are turned off or they're at a much reduced schedule. Those things, especially if something's been turned off for a long period of time. Belt drives not intended to sit under tension for long periods of time. That's intended to rotate. And if you're not going to have that rotating, removing the belts is an important step to making sure that when you go to start that system back up again, you reinstall those belts, and then you're in good shape. Belts don't like to sit static, idle for long periods of time. So there's a lot of stress on equipment in general when they've been turned off for a long period of time and you flip the switch and turn them all back on. So from our perspective, from the belt drive's perspective, what do you do after an extended period of shutdown? Check the belt for any signs of wear. You'll see cracks, you'll see sidewall wear, you'll see other signs of visible damage. If you see any of that, just change the belts. If the belts haven't been rotated and are under tension, again, the thing about belts is it's a rubber material. And if you have that under tension, you're squeezing the belt where it's in contact with the shiv, and it's under tension even in the area that's exposed to the air. That's going to force the oils out of the belt, which is really the number one mechanism for belt failures. So if they're under tension for extended periods of time, before you start that thing back up again, again, we recommend changing the belts. They won't necessarily catastrophically fail the moment you start them, but they'll have a dramatically reduced life, and then you might get sporadic failures at an inopportune time when you're not really in a good position to be able to change them. You also want to check the shivs for wear. So shivs will have signs of rust. They'll have signs of wear that might have been as a result of the shiv really needing to be changed a long time ago, but hadn't been changed. But if they're sitting there static, there might be some condensation that formed, and that condensation obviously can cause rust. Rust corrodes belts. So if you've seen any rust on the shivs, again, change them. And then when you talk about wear, I'm going to talk about this a little bit later as we get into more of the efficiency section. But if there is greater than a 32nd of an inch of wear, that's when you want to change the shivs. So the third step, obviously, once you've changed the shivs, changed the components, you want to check belt tension. You want to make sure that your belt tension and your drive alignment are proper. We recommend using a tension checker and then a straight edge or a string for alignment. That'll help get you best performance. And then step 4 is if you've had difficulty releasing the belt tension due to seized or broken motor bases, we consider, or we're asking you to consider to make an upgrade to a tensile set motor base. Again, I'll talk more about that later as well. All right. Pause there for a second to see if anyone has any questions on any of this stuff so far.
Hey, Jesse, it's Sean.
Yep.
Ian, also, I just wanted to make sure that folks know the poll question, the icon on the right-hand side. Just take a break. It's I think we've got 2 poll questions. One is closed, one is open.
Yep.
Just to double check that before we continue.
Yeah, and I did notice that from the poll, what I'm seeing is about 50% of the people have actually made the upgrade to MERV 13 and 50% have not. So that's interesting. Again, the importance of making sure that you're upgrading that filtration, that has a very significant impact on obviously the risk mitigation and really, what we're seeing right now with the cases increasing speaks to the fact that we as professionals who are in charge of people's safety really need to make sure that we're doing best practices to ensure that we're doing everything we can to keep people safe, and improving and increasing that MERV filtration level to 13 is a really important step. And obviously
I'm guessing that may have something to do with the poll question too, that folks are participating at a certain rate here.
Yep, that's possibly true for sure.
Yep, and then the first Q&A question came in, which is about how long should a shiv last, but I know there's a slide later on, so we'll get to that one.
Yeah, absolutely. Good question. That's a good segue for a later conversation.
Yeah, very good. Yep.
Okay, so let's talk now about when you increase that MERV rating. This chart at the top here, what this shows is, if you remember going back to that 3 slides ago, that MERV filtration exponential curve of the risk mitigation that happens as you increase filtration, this now shows that proportionate increase in resistance that MERV filtration has on the overall system. And then that's the blue line that you're seeing. The red line represents belt drive efficiency. And that decay that you see in efficiency is only there when you have a belt drive in what we consider a typical maintenance state, which is, worn shivs, under-tensioned belts, worn or used belts that have been on for quite a period of time. Belt drives in that state, in that situation, aren't operating at their peak efficiency to begin with. And once you start to increase that MERV rating and increase that resistance on the belt drive, that decay is just going to again exponentially drop from an efficiency standpoint. So I'm going to speak to the importance of making sure that all of the components are in peak condition so that you can ensure that you're getting peak performance. So what you need to consider is belt drive tension. You need to look at the belt type. You need to look at shiv wear. You need to look at alignment. And one of the elements that I'm going to speak to as well is there's different types of systems, as you all know. There's variable air, there's constant air. If you have a variable air system, what happens in those systems is the VFD can compensate by just increasing the speed of the motor. But again, we talked about this a little bit in the beginning. When you talk about efficiency and you talk about the belt drive and the motor, there is a price to be paid by having that motor increase in speed. And that price is energy. It'll consume, per the affinity law, a cubic relationship of energy when you increase speed. So you're really going to be driving a lot more energy consumption if you let that variable air system just compensate for an inefficient belt drive by speeding up. And if it's sitting at 60 hertz, which I've seen a lot. I've seen a lot of belt drives that are inefficient to the point where even though they've got a VFD on it, that motor's still sitting at 60 hertz because the belt drive's just flipping so much and losing so much efficiency that the motor's got to be flat out for you to produce as much air as you can. Then if you're sitting in that situation and you increase the MERV rating, you're just going to decrease the air volume that you'll actually be producing. So, and if it's a constant system, if the belt drive decays, then you're losing airflow. It's as simple as that. So again, these things are important. They're important considerations. All right. So let's get into the 5 specific steps now. Upgrading from wrap to notch, that's your first step. There's a 3% efficiency that can be gained in making that upgrade from wrap belts to notch belts. I should note that wrapped belts, those are the ones that are, they've got a fabric sidewall, they're smooth edged, they've got no notches on the bottom, and a notched V-belt, those of you that can see me, that's a notched V-belt right there. That's got notches. It's still a V-belt. It still fits into the angled sidewall shiv, but it's got notches. Now that's different than a synchronous belt. Synchronous belt actually runs on more of a gear type of pulley. Totally different system. So I wanted to make sure that distinction was known. Tension. This is again one of the things that I think people overlook more than anything. How to make sure that you're operating at proper tension. You can lose 5% efficiency if this belt drive is under tensioned. And then replacing worn shivs. We'll talk about this more in detail, but you can lose 5 to 8% efficiency with lost or with worn grooves in the shivs. So again, we talked about a 32nd of an inch. If you've got that much wear, you need to replace it. Step 4 then is a self-adjustable motor base. You can gain a 1.5% efficiency using a continuously adjustable motor base, and I'll get into that in a bit. And then the 5th step, motor efficiency. One of the things that most people don't really think about when they think about the motor and whether to make an upgrade, a lot of people don't upgrade a motor based on efficiency. They upgrade a motor when it fails. And the thing about motors is, there's a lot of standards, NEMA standards and things that require manufacturers like Regal to make motors that are of a certain efficiency. So you can't buy a motor today that's at an efficiency that it was back in the 1980s. But you do have the opportunity when you go to upgrade these systems to look at the motor efficiency. And if that motor efficiency isn't up to what you could get today, there's calculations we can help you make. We've got an app that has a motor upgrade efficiency calculator that can help justify that upgrade based on the energy consumption that you'll save over the lifetime of that motor. Okay, getting into now the specifics of the belt.
Hey, Jesse, I was going to kick off another poll question that the people can answer as this is going, related to how important is energy efficiency to your clients. So that will show up in a second so they can answer that, and we can see the results as we go through these slides.
Yeah, that's great. Energy efficiency in general translates in a bunch of different ways. Energy efficiency obviously means the more energy you're consuming, the more cost you're spending, so that's important. I find that depending upon the individual audience that we're talking to, some of the contractors that I've worked with and that I've talked to have said, my clients care about efficiency. They care about the electrical energy that they're spending, and we look for solutions that help to reduce or mitigate some of that cost. So doing these things, there are tools that we have that I'll speak to a little bit later on. There are tools that we have that can actually quantify and capture this and give you tangible numbers that you can present to your clients that say, look at what we've done. And some of these buildings have dozens of belt-driven systems, and having an ability to quantify the energy savings by making very simple upgrades. Like, these upgrades are nothing special, nothing fancy. They're not huge capital costs. These upgrades, often, some of them are just best practices of techniques that you should be doing or could be doing all along. And it's just easy, simple ways of quantifying. So speaking now in terms of the belt and wrapped versus notched, wrapped versus notched, here's a question I've had for years and years and years, which is I don't even know why people still put wrap belts on. Wrapped belts were designed probably, I think it's 102 years ago, and have not been really upgraded all that much in the last 30 to 40 years. Notch belts, notch belts are much newer, but even those belts have been out for decades. So when I look at the difference between the two technologies, wrap belts, they're 95% efficient. Notch belts, they're 98% efficient. Notch belts transmit more power. The difference between them is there's a fabric wrapper around a wrapped belt, and the notched belt, or cogged, if you will, is a raw rubber edge. So it's got a better coefficient of friction. That better coefficient of friction is actually through the life of the belt. If you ever look at wrapped belts when they wear, when you pull them off to change them, the sidewall is always glossy. And that's because it's a fabric that's impregnated with rubber during the manufacturing process when they wrap that fabric around it. Obviously, in the first, certain number of hours of service, that rubber is going to start to wear away, and then you're going to be left with that fabric. So what happens with wrap belts is they might be nice and efficient the minute you turn them on, 95%, but that efficiency decays pretty much right away from the moment you start it, and continues to decay through the life of the belt. Notch belts, they'll maintain that same efficiency, or that same coefficient of friction throughout the life of the belt due to that raw rubber edge. It's a simple upgrade. If you've got a B48, you're going to put a BX48 on it. So all that you need to remember is that X denotes a notched belt. So for this simple recommendation, if you've got a bunch of wrap belts, upgrade them with notched. Really simple, easy to facilitate. The cost differential between the two is more than compensated for by the energy consumption you're going to save. Just as an example, if you think about a 20 horsepower motor, that 3% in terms of the electrical energy consumption, you're going to save about $200, $250 depending upon the kilowatt hours that you spend for electricity in the building. And that upgrade for that belt is going to be $10 at most. So it's a really, really easy ROI. Okay, talk about belt tensioning. This is one of those things that I think everybody, if they were honest with me, would tell me that they don't really do the requisite retensioning that the manufacturer recommends. I mean, we recommend installing belts, tensioning them, turning them on, running them for 20 minutes, shutting them down, tensioning it again, checking it after 4 hours, checking it after 8 hours, checking it periodically thereafter, and at least every quarter retensioning it. Most people don't do that. And I get it, it's time consuming. But, you're going to decay efficiency for every percent slip that you're increasing. And, if you roll on belts, or if you move that motor base back and forward to a preset location that you've drawn on to, the frame, all of those things don't really tension the belt to the proper levels. You really actually need to use a proper tension checker, and we recommend using a tension checker to make sure that you're tensioning it to the proper number. So the other thing that we'll mention is, in terms of efficiency, we've got a self-adjustable motor base. I'll talk a little bit more about that later. That helps you to maintain that efficiency through the life of that belt. So 95% of all belts fail because they're under tension. That's a poll that we've asked so many users, so many contractors over the years, and compiled the results and determined that that's the number one cause of failure. And that cause of failure is usually as a result of improper maintenance or best practices when it comes to installation of the belt drive. And I get it. There's a lot of challenges to maintaining a belt drive. They are very labor intensive, and often you've got much more important things that you're working on, and this gets neglected. This gets neglected because you really can't see that efficiency. If that fan is spinning, and you often think you're good to go. Okay, I mentioned in the earlier section that I had something new to talk about. Browning is about to launch a new notched belt, and we're very excited about this. This is probably the first really innovative advancement we have made in belt technology in at least the last decade since we went to EPDM rubber. And before that, it's been a quarter of a century since any real significant performance improvements have been made in belt technology. So this new Browning notch belt, we're calling it the Torque Titan. This is the industry's first zero maintenance V belt. And by that, I mean the cords themselves and the rubber material and the means of adhesion of the top layer with the bottom layer are all designed such that you actually don't get stretch of the belt anymore. So we've also done things like FEA, that's finite element analysis. That's a means for us to determine where the stress points are within the belt. We have designed this notch to be the most efficient notch design that you can get out of a belt. So that's another advancement that we have made. You'll see many different notch designs from many different manufacturers out there. And this design is essentially the best of the best of the best. We looked at I think we looked at 30 different iterations of notch designs and tested all of them from a finite element analysis standpoint and determined what the optimal notch design was. And this is it. So what that means is that actually reduces the bending stress. So if you think about a belt, the motor's got to actually bend the belt around the sheave. And that requires a lot of work for the motor to do, and that's electrical energy consumption. So by us optimizing that, we've dramatically reduced that amount of tension or the amount of work that the motor has to do there. We also have a new generation of EPDM rubber. So that new generation has allowed for this rubber material to be much, much stronger against those cords digging in. So you can get a lot more tension that you can apply to this belt now. So all that's to say that it actually transmits 30% more horsepower than our previous notched belt. So this again is another quantum leap forward in the belt's ability to transmit power. So you see there on the right, the top right, no need to retighten the Titan. Can't stress the importance of that enough. This is the first zero maintenance V belt. If you see that black line there, that's typically what you experience with belts in terms of their tension. That tension decays right away in the first few days or the first few weeks of service. You're supposed to go back, you retension it, and then it continues to decay over the life of the belt. Our belt actually doesn't decay anymore. So the only thing that happens is rubber wears away, and that rubber wearing away does eventually result in the belt failing. These are not infinite life belts, but you're going to get better performance throughout the life of the belt than ever before. What you're seeing on the bottom right is this is a drive that would, how many belts would be required on the drive if it was designed and made with a B section wrapped belt. Then if you look at the 5V section belts, you're seeing that we go from that 6 belts down to 4, and then again, further improving that down to 3 or 2 with the Torque Titan. So that's another significant improvement in our value proposition of being able to redesign drives and improve the overall systems by reducing cost. You're able to reduce the number of belts, which reduces the number of grooves. And obviously, as you know, the iron is the most expensive part. So if you can reduce the number of grooves, you're dramatically lowering the cost of the replacement.
Hey, Jesse, so before you jump to the next slide, so the 5 steps for the HVAC energy efficiency. When first step is upgrade to notched belt. So the Torque Titan will give you a little bit of a benefit there, correct?
Yep, correct.
And then the properly tension your belt, it's going to help you with step 2 as well.
Yep.
Okay.
Yeah, actually, we're kind of killing 2 birds with 1 stone. That's a good point. We've recognized that a lot of the limitations and a lot of the challenges that people had in belt drives was maintaining them. And that's really what went into the design of this new notched belt, is to eliminate that need for constant retensioning, for constant maintenance. And then we've just managed to also improve the overall performance of it. So, need less belts, less screws, all that kind of good stuff.
Hey, I just wanted to mention a couple of anecdotal things. In a time like this, when everything's kind of iffy in terms of what's going to be in the next year or two, a lot of the conversation, in a joking manner, is what's going to go away first, Sean or belt drives. This is a very interesting innovation in that and I know many of you chiefs do sit around in these conversations when we're talking about capital improvements and are we going to use EC motors and direct drives. This is a situation where, from a maintenance perspective, not a capital perspective, you can put in a system that's highly efficient and very low on maintenance. Next best thing to an improvement like that, and eliminate that maintenance at the same time. So I was fascinated that these guys had undertaken this process of developing this V-belt. Jesse, can you go back to that last slide that you had on there?
Yep.
Many of you chiefs remember a time when a belt drive came out that was a synchronous belt, and the image looked very similar to what Jesse has on the lower right of his screen, where they would show a 5 or 6 groove B or C section belt, and then on the far right they would show you what was their synchronous drive, what some companies call HBT, some companies have a name called I forget what that brand name is. It's a situation where some of you may have a connotation that far right belt might have been a synchronous drive, and that had some very negative connotations for you. Just want to reiterate, and Jesse, you can expand on this, that innovation it's a BX or an AX or a belt that doesn't require a change in shivs unless they're worn. There's no direct drive. And if you look at that, the thing that's impressive to me is the weight issue. So Jesse, if you could expand on that a little bit before we lose me, Jesse. Also, if you could touch on 4L, 5L versus AB in terms of the horsepower ratings just a little bit, because I've had some questions on that in the field. Thanks.
Yeah, no problem. So I'm actually holding in my hand the new Torque Titan belt. So hopefully you guys can see me. If you can't, it's just really the belt that I showed you on the prior slide. But to Sean's point, it's a V belt. So this is the same belt that will run in the same shivs that you've currently got. So if you've got an AX belt, a BX belt, a 5VX belt, a 3VX belt, you can make that simple upgrade to the Torque Titan by just changing the belts for the new one. So it's a very simple upgrade. And again, what we did, to Sean's point, is we kind of looked at, where do we innovate? Where do we spend our money in R&D? And some of the pushback that I got was, well, if customers are all going direct drive, why are we going to spend a bunch of money on innovating a new V belt? And my response was that, I got probably 20 more years of work in me, and I'm going to be retired long before we've designed out every single belt drive. And the reason is because if you think about it, if I can operate a belt drive at 98% efficiency, and if I can remove all of the maintenance elements that are the negatives to a belt drive, 2% gain in efficiency by going direct drive, how much is that really? And what's the capital investment that you have to make? And again, to put some numbers to it, if you got a 40 horsepower motor, you're talking about probably that 2% improvement to go from 98 to 100 is a couple $100 a year. And if you've got to spend $20,000 on a capital improvement project, $50,000, you will never recuperate the money. Absolutely never. So I know that there are a lot of applications out there where it just does not make sense to try to go direct drive. Belt drives are easy to maintain. We have a huge network of belt suppliers belt distributors all across the country that can help to facilitate new belts and the maintenance and the repair of them or the replacement of them. So we don't really worry about customers saying like the Synchronous, oh man, where can I get that? And Synchronous is really noisy. Yes, it is. There's a lot of negatives. We have Synchronous belt drives. but I don't ever recommend them in an HVAC application. Our applications are heavy on noise, meaning it's important to not have it noisy. You don't want that vibration to go down that ductwork into the space and have people having to hear this. So this operates just as quietly as any of our current belt drives do. Weight savings, Sean mentioned that. If you're able to reduce the number of grooves, we've gotten to a point, there's a bunch of applications I've retrofitted where it used to be 2 guys and a cherry picker putting that shiv on because it was so big and so heavy. And it dropped it to a point where it was 1 guy, a big guy, mind you, but 1 guy being able to pick it up and drop it onto the shaft. So there is a significant improvement in just even the weight of these systems, reducing the amount of people that you would need, reducing the amount of time you would need to install it. Again, it's better. It's just the next generation, and it's much, much better. So shivware.
Jesse, I'll start the next poll question right now just so they could answer it related to how often do they replace shivs?
Yep. The last poll, 100% were energy efficiency was important. Not everybody answered it, but a majority of the people did. So there was an importance to energy efficiency, definitely.
Yeah, and everybody said it was very important. So that's good to see. Yeah, so pivoting now, talking about shivware, I'll answer that question that came in. Shivs should be replaced after 5 to 7 years of service. I'm answering the poll question, by the way. So. Shivs should be replaced after about 5 to 7 years of service. So if you think about the buildings, I've been to a lot of buildings. Actually, I've been to a lot of buildings in New York, and I've learned that some of the shivs are the same age as the buildings. So it's definitely something.
We're not naming any names, right, Jesse?
Nope, we'd never do that. Absolutely not. Not pointing fingers here. It's one of those things where it's, again, another misconception. A lot of people think that the shivs don't wear out, right? I mean, it's steel or iron, and we're talking about a rubber product running on it. So why would the iron wear? Why would that wear out? And really, if you think about it, both materials are wear items. Shiv wears, belts wear faster, mind you, but shivs do wear out. And for those of you that can see me on the screen right now, I'm squeezing the top of the belt and the bottom of the belt, trying to deflect it. And it's hard. Belts are actually, even though they're rubber, they're really, really, really hard rubber. So they actually don't conform to a worn out shiv like you would think that they would. And what happens then is you actually don't get full engagement of the belt against the side of the shiv, and therefore you don't transmit the right power. So again, you're causing slip. Again, you're causing heat. And again, you're causing inefficiency. That all reduces the airflow. Belts could be unevenly loaded. If we're talking about different wear, you might not have changed the belts at the same rate, although most people do. You never want the belt to bottom out, as you're seeing in the picture on the bottom right. You never want the belt to ride on the bottom of the shiv. All that's to say is a 32nd of an inch is the amount of wear that we have determined results in enough decrease in surface area contact that shiv doesn't transmit, or those belts don't transmit enough power anymore, and that's worn out. 32nd of an inch, to put in perspective, is like the diameter of a human hair. So really what we recommend is using a groove gauge. Stick that groove gauge in that shiv, shine a flashlight behind it, and if you can see daylight between the actual groove gauge and the sidewall of the shiv, it's worn out. You could see there with a straight edge. You can do it with a straight edge as well. That's also very typical of the form of wear that you'll see. You'll see in about the middle section, right where the cords actually contact the shiv. That's where they wear out. All right, so I mentioned this a couple of times. Self-adjustable motor base. Browning's actually designed and developed a self-adjustable motor base, which takes care of a lot of issues, a lot of problematic challenges of typical belt drive maintenance and installation. How many people, if I'm asking honestly, how many people roll on belts? Again, most people would say they do. And you roll on belts for a number of reasons. You roll on belts because the motor base might be seized. You roll on belts because you don't have enough time. There's a lot of reasons. You roll on belts because you just don't know any better. There's a lot of reasons why people roll on belts. The guy before you did it that way. He taught you, you do it that way. Fact of the matter is, if you roll the belts on, what happens is you actually are going to fracture some of the actual cords of the belt. And if anyone's ever had a belt in an application where it's rolled off, the belt's literally spun out of the sheave and you see the belt on the floor, that's because you rolled it on, you fractured a few of the cords on one side, it loaded it fully on the other side, and it just spins out. That's just what happens. So we've designed this self-adjustable motor base to run on 2 linear rails on each side, and then there's a central point where you change the tension. So the thing that's nice about this is most motor bases, they walk forward and backward as you're tightening a nut on each, or a bolt on each side. And that walking it forward and backward makes it very difficult to increase or decrease the tension, to take the belts on, to put the belts on, or to take the belts off, put the belts on. It's a challenge. So we've put a central threaded rod in the middle that you can use an impact gun if you want and hammer that thing on and off. Just do it carefully. But it's much, much faster to do. There's a spring inside of it, which actually also holds constant tension. So you make sure that you're operating at 100% tension throughout the life of the belt. You have no initial tension decay. You have no airflow. You have no loss of efficiency. So this motor base, not only does it maintain constant efficiency, constant alignment, it also increases the life of the belts. And it does that because if you think about the energy coming into any building from the utility, from the power company, that energy has hills and valleys and spikes as it comes in. And all those spikes are loads that go into the motor. The motor translates that into the belt, and the belt sits there doing a vibration. And it's microscopic, you don't see it, but it's a consistent, constant shock loading that's going through the belts. So that spring actually takes up all that, smooths that rate out, and also helps to provide an energy savings by taking it and smoothing that energy profile, that energy signature of the motor. So speeds up the whole installation, helps maintain the constant tension, increases belt life. It's a great product, and I highly recommend it for those of you that have, difficult applications where, you can't maintain the belts, or you want to make sure that you've got maximum life that you can achieve.
Hey, Jesse, I have a comment and a question.
Certainly.
We've got multiple attendees here that are using the self-adjusting motor bases successfully, and I know we have some that are not. But I wanted to ask a question. From a practical nature, I know that as technicians assess or go to do either their walkthroughs or their PMs, there are a number of ways that they can tell that they've had or have a tension problem. I know one of them is a heavy black dust. What are some of the other indicators that they can look for as a walkthrough and as a PM, where they can say, look, you know what, this stuff they talked about in this seminar, in this webinar, I think we have these problems. What are some of the things that they can look for? And I know we're running out of time, but I thought we could answer that one quickly.
Yeah, really easily. How long does a belt last? If your belt's lasting less than a year, you have a tension problem. We have designed our belts to last 3 years at continuous service. So if you're not getting 3 years out of the belt, then you have a tension problem. Dust, sidewall dust, as you mentioned, is a good one as well. If you're getting premature wear on the motor sheave, that's also a sign that you don't have proper tension. If you have uneven wear, that's a sign you've got improper tension. Alignment can also result in that. If you've got one groove that's wearing more than the other, that's improper alignment and improper evenly loaded. So there's a bunch of indicators that can tell you whether or not you have proper tension or not. But one of the other ones is when you look at the belt when it's running, if it's jumping, and by that I mean it's like vibrating or pulsing, that's another indicator. So if you see any of those telltale signs, if you see belt dust, if you see that your belts aren't lasting very long, if you see that it's vibrating or oscillating when it's in service, those are indicators, and the self-adjustable motor base can help address those. Okay, so wrapping all that up, taking all those nuggets that we just talked about with the 5 steps, replacing like for like versus retrofitting. We talked about the higher horsepower carrying capability of the belts. We talked about the need for replacing worn out sheaves. All of that allows for us to, instead of you just changing out like for like, let us have the opportunity to redesign and optimize the system for you. When we do that, we can take this is a 50 horsepower motor that you're seeing on the left with its old C-section 95% efficiency at its best the day it was installed, whatever that was 20 years ago. Taking that and upgrading it and retrofitting it to the one on the right is a service that we actually have available to you. We will quantify the energy savings and the cost savings due to that energy reduction. We will quantify the maintenance reduction, through the self-adjustable motor base and how that reduces the amount of times you have to retension it. We will quantify the cost savings as a result of going from 4 belts down to 2. The sheaves will be less expensive. We even get a belt savings. I talked about the notch belt being more expensive, but if you think about it, if each of those belts on the left are $20, then that's $80 worth of belts. If the belts on the right are $35 each, then you're talking about $70. I just saved you some money. So that's an opportunity that we have to help you. So I'm going to fast forward now to our services that are available. We have got a 1-800 number. That's our application engineering team. We've also got an email address that you can email us. We have got a 24/7 online edge selection tool that you can use yourself to optimize your belt drives. And then we've also got an app, and that app allows for you to use via Android or iPhone. You can input the parameters of the drive straight into the app and hit submit, and our application engineering team will go through the redesign process for you and give you a bill of materials for the retrofitted and upgraded components, and we'll also give you a documented cost savings of the improvements and the quantification of those improvements. So with that, I will leave it. There's our Facebook page, there's our LinkedIn, all our contact stuff. We're online, our presence is good online. If you have any questions, feel free to shoot me a note. There's my contact information at the bottom. I'm going to wrap up with that. I'm going to ask if there's any last minute questions that anyone has that I didn't speak to throughout the presentation. And I'm going to thank you for your attendance.
Yep. So Jesse, we did get one comment that one of the people online is using the adjustable motor base, and it can tell us it's a great product. So that was some good feedback. Thank you. Question on the Torque Titan. Is it available today? Part number change? What's the launch plan?
Great. Yeah, good question. So we are launching this in mid-January. So mid-January, we're going to start releasing AX and BX. This is going to be a rolling change for Browning. So we are making no changes to our part numbers. So when you ordered an AX 48, a BX 62, tomorrow or in January, you're going to now get a Torque Titan. You will see the label Torque Titan on the belt. That's how you'll know that it's the upgraded belt. We're just discontinuing the old one. There's no point in having both. This is, like I said, an innovation improvement that we've made to the product line, and there's no point in having both. So it'll be a rolling change. It'll happen from about mid-January when we're finally transitioned all the belts over. It'll be about mid-March, and everything that you'll get from Browning going forward will be of the Torque Titan configuration. So, if that is something that you're looking to do, feel free to take advantage of the design services that we've got and allow us to optimize the drive take advantage of the higher horsepower carrying capability of the belt and reduce some of the cost.
Great. Now, Sean, I mean, how does, how do you fit into this? I mean, what services do you provide to help the, those that are on the webinar with us?
I think as most of the guys, most of the attendees know today, we are locally capable of helping with these drive designs. We've been doing it for a long time. It's great to have the vendor support, the manufacturer support that you guys provide. It's really a question, as some of the attendees know, these things are really a question of what Jesse began the entire presentation with, is how important are they? Some people, I've had the joke, people have said to me, all our belt driver maintenance free. But, I know by seeing the attendance list that there are some very good chiefs and technicians here. We do provide training. We do provide local support. I know there was a question about some tools here. I'll get some follow-up out there. I'm available. Our information is out to everybody, and we'll follow up in the meeting today. For those of you that are here, there's another session today at 3 p.m. If you have night shift folks that you'd like to attend, you can certainly register and do that on time.
Yep, great point. And then the other thing we will do is this is recorded, so we will edit a little bit, and then we will post it, and then Sean will be able to email it out to everybody. Because we had everybody tried. We had some people that were unable to attend, or you may want to share it with some of your staff. And
if we get some questions during the day, if you want to email me questions, we'll make sure they're part of the 3 p.m. session as well.
All right. Looks like we got about a minute left. So want to be cognizant of that. Any last minute comments, Jesse?
No, I'm good. I think the questions were great. I liked the feedback. I was pleasantly surprised to see some of the answers that people gave. It's an important piece of technology. I want to reiterate that. It's an important piece of the overall system. I mean, if you don't put any belts on, you get zero airflow. So they obviously play a role. And I think that you've all kind of alluded to understanding that fact, and that's great. Now I just want to let you know that we're here to help in making sure that it's at its best. We have tools and application engineers that are waiting to help. Use them.
Perfect. Well, again, thank you for Jesse and Sean, and thank you for everybody that attended. With that, we're going to wrap up. Stay safe, and looks like a bad snowstorm hitting the East Coast, so be careful out in New York. So. Again, thanks for joining. Sean will be following up with those that attended. And, as Jesse said, his contact information is there. And feel free to reach out. Have a great day, everyone.
See ya.